Lesson 1-8, Interpreting Graphs of Functions. In this video, you will learn to interpret intercepts and symmetry of graphs of functions, as well as interpret positive, negative, increasing, and decreasing behavior, extrema, and end behaviors of graphs of functions. So your vocabulary for this section: intercept, x-intercept, y-intercept, line symmetry, positive, negative, increasing, decreasing, and end behavior. Okay, first thing we want to learn how to do is interpret intercepts. So the graph shows the costs at a community college, Y, as a function of the number of credit hours taken, X. Identify the function as a linear or nonlinear, then estimate and interpret the intercepts of the graph of the function. So first thing we want to do is look at this and see if it's linear or nonlinear. Now, linear means that it forms a straight line. Nonlinear would be anything that's not a straight line. So when we graph those values in our graph, do we have a straight line? Yes. So first thing we're going to say is that it's linear. Okay, and then it says estimate and interpret the intercepts of the graph of the function. So the intercepts are where they touch either the x-axis, this line here, or the y-axis, this line here. Now in our graph, it does not touch the x-axis. If we were to continue this out, it would be going, and it would touch somewhere in the negatives. But because we can't have negative credit hours, that just doesn't make sense to have negative hours, we're not concerned about the x-axis in this case. So we're just looking at the y-axis. So looking at the y-axis, it touches about there, which is at about 50. So we can say that the y-intercept is 50. But what does that mean? So that means that the initial cost, when you're not even taking any credits, probably just to enroll in the school, is probably $50. So you can say the cost to be a student before taking any classes is $50. Okay? So you guys interpret the x and y intercepts from this. What do you think the x-intercept means? So again, that's when it touches the x-axis. And what do you think the y-intercept means when it's on that one? And say if it's linear or nonlinear. Okay, example 2, we want to interpret symmetry. So the graph shows the cost, y, to manufacture x units of a product. Describe and interpret any symmetry. So we want to look at this and say if there's any point on here that would show symmetry. So if I were to cut this in half, about here, everything that's on the left lines up with what's on the right. So this point here, 3 boxes away this way, is the same point height over there, 3 boxes away at 800. So we want to be able to interpret this. So we can say there's symmetry about the line. So in this case, it's 30. So we're going to say about the line x equals 30. So then we want to interpret it. So we can say 30, at 30, the price is at the lowest cost. It's cost least when you have 30 units. So when you're making 30, it costs the least. And then as you go further away from 30, either direction, it increases or decreases the same amount, or increases the same amount in this case. So if I went 10 units this way, it would be a little bit more than 600. If I went 10 units this way, it's still more than 600. So 30 is going to be the cheapest way. When you're making 30, it's going to be the cheapest price, manufacturing cost. So you guys describe any symmetry that you may see in this one. Okay, We want to be able to talk about positive, negative, increasing, decreasing, extrema, and end behavior. So a function is positive where its graph lies above the x-axis, and negative where its graph lies below the x-axis. So here, the blue represents positive because it's above the x-axis, it's above that line. And red represents negative because it's below the x-axis. So above, positive, below, negative. Okay, if we want to describe increasing or decreasing, when we read from left to right. We go that way. So if we think about this as like a roller coaster or something, if we put a ball on it, going from left to right, it would be first be falling. So when a ball would be falling, that would be decreasing. And then it would be going up the hill. Now it's increasing. And then it goes back to decreasing. So the blue here represents increasing. It's only increasing here, but it's decreasing those other two parts. Okay, so think about it as a roller coaster or a ball going down a ramp or something from left to right, just like we read from left to right. Okay, the next one is relative minimum and maximum. So if we're looking at this here, it's like the top or the bottom of a hump or a valley. So if you think about this as like a little pit, that lowest point in it, that's going to be a relative minimum. And this one here is going to be a relative maximum. We have to say relative because we're saying relative to what's around it. It's not going to be the absolute maximum because if I think about this point here, this point is higher than this one here. So it's not the absolute maximum. It's just a relative maximum. Compared to the things around it, it's a maximum. Okay? And this is the same thing with the minimum. This might not be the lowest point on the graph, but in that hump, it's a lowest point. Okay? So it's relative maximum and minimum. Okay, you can have more than one in a graph. So if I had something like this, I would have this as a relative minimum, and this as a relative minimum, this as a maximum, and this one as a maximum. Okay, so you can have more than one. Okay, end behavior describes the values of a function at the positive and negative extremes of its domain. So if I'm looking at the ends, I'm just looking at the arrows at the end. What are they doing? So as I go negative on my x, what is my y doing? It's increasing. So as you move left, the graph goes up. As x decreases, y increases. So x is getting smaller, but y is getting bigger. Okay, and then as you go this way, as you move to the right, the graph goes down. So we can say as x increases, y decreases. Okay, so you guys look at this and describe each of those things. So the graph shows the population, y, of deer x years after the animals are introduced on an island. Estimate and interpret where the function is positive, negative, increasing, and decreasing, and the x-coordinates of any relative extrema, and the end behavior of the graph. Okay, so I'm just going to talk through these and then I'll put up the answers. I'm not going to write them right now. Okay, so first one, we're looking to see where it's positive. So if I want to look to see where this is positive, I want to look to see where it's above the x-axis. And all of this is above the x-axis. The x-axis is down here. So we want to interpret where the function is positive. We're going to say from, so positive, we're saying from 0 to about 5.5, because then after that we don't know. So we put those in like little brackets. Okay, and then we want to know when it's negative. We don't have any sign of where it's negative. It's not shown on our graph, so we're just going to say nope. Then increasing. So remember, they're talking about the ball from left to right. So first it starts decreasing. So here, decreasing. So like we can say decreasing from 0 to 1, and then it starts increasing. It goes up, 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 up. That's increasing from 1 to 4, and then it goes back down, decreasing from 4 to 5.5 about, and then we don't know past that. Okay, so increasing and decreasing we took care of. The next thing is x coordinates of any relative extrema. So those are max and mins. So we're looking here, and this minimum, this is a minimum because it's the bottom of a valley, or a little loop. So, and the coordinates is 1. So the x-coordinate is 1, and you can, if you wanted to, go ahead and say that that's 60, 160. That's okay. But they just asked for the x-coordinates. And then we have a maximum as well. And we can say that's about there, which is at like 4, 140. Okay, so the x-coordinates of the maximum min are 1 and 4. Okay, and then and behavior of the graph, we can say here, as x decreases, y increases. So as I'm going this way, this arrow is going up. As I go this way, so as x is increasing, y is decreasing. Okay. So if you missed any of that and want to write it all down, here's about the same information. Looks like they rounded some things a little bit differently than I did, but that's okay. 7.5. Except for that 7.5, I don't know where they got that. Okay, so you guys try this one. And that's the end of lesson 1A.